Hi, so let me introduce you. No, we need screen recording to start recording. Hi, let me introduce you a little bit to the stuff in your game and to the ways that we talk about it. So up here, the very first things that you were doing were defining things like the title of the game. And this title is just a name, and the title color is just a name for this thing in quotes, and anything in quotes we call a string. We have defined 4 names here for various strings, and then we start defining images. Image URL is a function that makes an image out of whatever it finds at this web address. Flip horizontal is a function that takes an image, one produced by scale, and it makes another image. It's just flipped. Scale makes things bigger or smaller, and clipart URL is like image URL. It's a function that makes images out of URLs. But then, when we were making things move, we started defining not just names, but groups of names. You see this group of names is in a set of parentheses. That's because it's a function. The name of the function is always after a set of at the start of a parenthesis. And then the names of the inputs go from left to right. And we're going to codify that as rules that will help you understand all of where the parentheses should go and where they should go. So imagine for a moment that all of these parentheses are really not just left and right parentheses, but they're actually part of a circle. Okay, so they are the left and the right part of a big circle. That will help you remember that the parentheses always go together. And here, Dr. Racket will highlight the parentheses that go together to help you remember that too. But every circle needs to be closed, because what kind of silliness would it be for a circle to be missing some? You can't have that. So you can't have an open paren without its close paren, because the closed paren is what lets you have an entire circle. Now let's say that I just put some things in here, like maybe a function like plus, and maybe a 4, and maybe a 5. Now, this is going to come out 9, because 4 plus 5 is 9. But how do we know if it's 4 plus 5 or if it's 5 plus 4? So 2 rules are going to help you figure out circles all the time. Rule 1. I will undo that. Rule 1 is that we have inputs from left to right. So all of our inputs to a function, the order will matter. Old X and 11 are in a particular order. If I said 11 and then old X, it would be different because we're using minus here. And if we had 4 minus 5, that's different than 5 minus 4, because 4 minus 5 is -1, and 5 minus 4 is +1, +1. So instead of all this, let me write just the function at the top, minus, and then the inputs go from left to right. Let's say it's 5 and 4. Okay? So that's all well and good. But what about when things get a little bit more complicated? What about when we have more than one function? Like, let's say we've got a minus and a times, and we've got a 4 and a 2 and a 3. Okay, so now is this 4 minus 2 times 3? Or is this, let's pick a different color. Let's say red. Or is it 4 minus 2 times 3? And now we're using mathematical parentheses. These are not the same as scheme parentheses. Scheme parentheses are not just for grouping. they are actually these circles, and it's just that you only see the edges of the circles because it's hard to type entire circles. So let's see. How do we fix this? Rule number 2 will help us fix this. Rule number 2 says one function per circle. So what are the functions here? The functions here are the minus and the times, just like the functions here are the minus and the make posin, okay? And we'll have to separate these so that there's just one function per circle. Let's say we want to do this one, okay? Then we'll make a circle, and inside it we'll make another circle. We'll put the 4 here, right? We'll put the 2 and 3 here because they're grouped, so we'll put them into their own circle. And we'll put the times here because that's what we're going to do first to the 2 and the 3. And then we'll put the minus up here. Okay? If instead we wanted to take our blue color again and make the other one, make the 4 minus 2 times 3, then here's what we might do. We might have 2 circles the other way. So what would go here? The 4, the 2, and out here we would have the 3, because it's 4 minus 2 times 3. And then the minus is the function that applies to the 4 and the 2 in order, and the times is the one that applies here. So when we evaluate this circle, then we expect to get 4 minus 2 is 2, 2 times 3 is 6, right? When we evaluate the other circle in red, then we expect to get 2 times 3 is 6, 4 minus 6 is negative 2. So that's the output. The output is negative 2 here, the output is 6 here. So let's see how to make that happen. If we click run, first of all, we run the game. But second of all, aside from the definitions window, I'm going to close the game. Aside from the definitions window where we've got all these defined things, we've got this interaction window now. And it says very nice, comforting things like all 46 tests passed. Isn't it good to pass tests? So what we're going to do is we're actually going to translate these circles back into scheme code. Okay, first we'll translate the blue one. We'll start with the circle. Okay, I'll pick another color. Let's say black. So I'll start with the circle, and the way I start with the circle is to have this left paren, right? Then the name of the function, so here I am, the name of the function is start and then a space, and then I'm going to do the inputs from left to right, but my very first input is a circle. So I'll start a circle, the name of the function is minus, then a space, then the inputs from left to right, 4, and then 2, right? Because I just skip down here, then do the 4, and then a space, and then the 2, and then I am ready to close this inside circle. So I'll close that inside circle with a paren, and scheme highlights the circle that I've just closed. And then I'll have a space, and I'm ready now to do the 3. And once I've done the 3, I'm ready to close the big circle. And we get 6, just like we predicted. Going over to the other side, I'll do the very same thing, and you can pause and do it yourself, or you can skip. I'll do the 4, I'll start the big circle with that left parenthesis right here, then the name of the function, that in this case that's a minus, then the inputs from left to right. The first input is a 4, then a space, and then we've got another circle, so I use my left paren to start that circle. Then we've got the name of the function. That's a times and a space, and then the names and then the inputs from left to right. So 2 and then 3. And then we close the inside circle, and Scheme will highlight that for us. And then we close, we're ready, and we close the outside circle. Because we're done with everything inside. We've said the minus, we've said the 4, we've said the 2, the times, the 2, the 3. We've closed the inner circle, now we're closing the outer circle. Boom, and Scheme shows that, and we press return, and the answer is -2, just like we predicted. So these two rules that we had, rule 1, that you have inputs from left to right, and that order matters, and rule 2, that we've got one function per circle, that will help us understand all of the circles. And we know that the very first thing inside any parenthesis is going to be the function at the top of some circle, and then we'll have the inputs from left to right, and maybe some of those inputs are themselves circles. So minus is the function that makes this circle, and what we're doing is we're subtracting 11 from whatever old x was. And what that means is old x has got to be a number, like we said. Old x is a number, old y is a number. So makeposin must take a number, because minus takes two numbers and makes a number, and another number, because old y is a number. And what does it make? It makes a position. Hope that helps you understand circles and where everything goes. Thanks.